This video asks us to decide whether or not two other groups that we've seen are isomorphic. We saw in the text that R is isomorphic to the positive numbers under different operations, R under addition and the positive numbers under multiplication. Now, what we're going to see is that R is not isomorphic to R star, where this guy means non-zero real numbers. Right, we talked about that in the last video, that the star means all the numbers with multiplicative inverses. And in R, every number that's not zero has a multiplicative inverse. The proof of this is really simple. Basically, what we do is we realize that if an element on the left has a given order, there has to be an element on the right of the same order. I'm actually not sure that we've talked about order before. So let me just remind us, order means the smallest power of that element, which is the neutral element again. If there is such a power. Otherwise, the order is said to be infinity. Now, what we notice is R star has -1 as an element. But under multiplication, right, the star means multiplication is the operation, -1 squared equals 1, which is the multiplicative identity. There's our neutral element. So in other words, R star has an element of order 2. The catch is that if you have two groups, A and B, and an isomorphism from A to B, if A has an element of order 2, or any order for that matter, order n, right, phi of A to the n would have to be E, because if A to the n is E, then, well, phi of E is E. And I don't think we've actually proven that yet. Maybe I'll say it a different way. That will be the same thing as phi of A to the nth power. And so it will turn out that phi of A will have to be equal to E also. I don't think that we've proven this, but the proof of this is really simple. And so I'm going to leave this to you as an exercise. Basically just solving equations in groups. And so for our purposes, with this observation in mind, since R star has an element of order 2, we can ask, does R have an element of order 2? Well, in R, the operation is just addition. So an element of order 2 would be an element such that x plus x equals 0, but that's 2x equals 0 or x equals 0. But 0 has order 1, not 2. Right? In other words, there has to be a non-trivial solution to this equation. And since we can't find it, there is no element of order 2. They cannot be isomorphic.